Hello, my name is Jonathan Tipo, and today I'll be talking to you about Système International or SI units. Wait, Jonathan, did I hear some French? I thought we were talking about chemistry. Well, you're right, you did hear some French. Well, that's because the SI unit or the SI system is used worldwide, right? So if you go to another country and you start talking in SI units, they will 100% understand what you're saying, right? So, that being said, there are 8 basic units in chemistry, right? There's a kilogram, meter cubed, second, Kelvin, ampere, candela, mole. And they all represent different things like mass, length, volume, time, absolute temperature, electric current, and luminous intensity. I don't know if you saw, but I had this little red underline because I know what you're thinking. Wait, that's not the units I'm used to when seeing volume. And I know we're used to seeing liters, and there's a conversion between this and liters, the meters cubed and liters. I'll get to that in a moment, right? But I want to also stress this last thing, which is the mole. What I'm about to talk to you about is not applicable to the mole. The mole is a different unit itself. So when you eventually do see it in later modules, you won't be surprised saying, oh, wait, what is a mole? You know, I never heard of that before. This is completely new. But you're hearing it right now. The mole is a unit. But what I'm about to talk to you about is not applicable to the mole. So I just want to preface that. So, SI prefixes. So you've heard of that, right? It's called milligrams. What about that? Milliliters. Centimeters. Kilometers, right? You've heard of those things, right? And that's because these things are part of the SI system. So, let's look here. You see that you got M, C, and K. If you look up here at our table, you'll see that we also have M, C, and K, right? And going back here, what do we call this? We call this the milligram. We call this the milliliter, the centimeter, the kilometer, kilo, right? So there are 2 parts of this, right? You got the prefix, and you actually got the unit, right? And so this is the gram, the liter, meter, and the meter, right? And so what I have here in brown, right, the gram, meter, liter, are what we call reference units. Reference units. And this is what this table is based upon. So you always want to start here at our reference units, right? And what are our reference units? Well, grams measure mass, meters measure length, and liters measure volume, right? So these are our reference units. And so we have these things, right? The milli, the M, the C, and the K. They're called prefixes, and in chemistry, prefixes are multipliers. Right, so for example, if I had, let's say, a teragram. Teragram. So 1 teragram would be equal to 1 times 10 to the 12 grams. And if you know scientific notation, you know that's equal to that. Super big number. Right? And let's do, works with kilometers. So 1 kilometer we know is 1,000 meters. But according to this table, it's 1 times 10 to the 3rd meters. But this converts to 1,000 meters, right? And so that's really how you use this table. So what I just wrote here, is 1 kilometer is equal to 1,000 meters. That's what we call a conversion, right? And here are a couple guidelines to a conversion. So conversions are something like 1 meter is equal to 100 centimeters, right? 1 liter is equal to 1,000 milliliters. So this is what we're calling conversions, right? So converting one unit to another using our table. So there are a couple guidelines to this. Guideline 1, always use a table. Obviously, I'm not going to give you a table if I don't want you to use it, so you always have to use this table. Guideline number 2, make the bigger unit 1. Right, as I said right here, it's easier for, at least for me, and it's easier for our brains to think of it as 1 meter is equal to 100 centimeters rather than 1 centimeter is equal to 0.01 meters, right? So guideline number 1, or guideline number 2, always make the bigger unit 1. Number 3, always use reference units, right? So what are reference units? Grams, meters, liters. So using reference units, how do I do that? So say I want to convert from teragrams to nanograms, right? Well, we don't know the straight up conversion from here, but we do know the conversion from nanograms to grams and from grams to teragrams, right? And so that's why, again, that's why we want to use our reference unit, because this table always going to refer back to the table, because this table is based on these reference units. And there's a final one which only works if you're using my guidelines that I have above. Only works using my guidelines. And basically it's this, right? If you use this one, then this tip only works, right? So scroll up. Say let's do this example, right? Let's do the teragrams to nanograms, right? So let's do this. Step 1, we always want to use our reference units in our conversion, right? So we'll go from teragrams to grams and from grams to nanograms, right? And if we're using guideline number 2, make sure the bigger unit is always 1. So if your bigger unit is 1, then you can just drop the sign, right? So you can drop the sign. So nanograms is 1 times 10 to the negative 9. You can just put 1 times 10 to the 9. And again, this is only working if you use my guidelines, the ones that I have above here. And so for teragram, we don't really have to worry about the sign because the sign is positive. So 1 times 10 to the 12. Right, and so we just made 2 conversions. And right here, I know it says up here on the table, it says 1 times 10 to the negative 9. You know, we have positive 9, right? Because we're using our guidelines, we can drop the sign. Let me explain to you quickly why it works, right? Let's use 100 centimeters is equal to 1 meter. We know this, right? 100 centimeters is equal to 1 meter. Well, if you see here, according to this table, 1 centimeter is equal to 1 times 10 to the negative 2 meters. Or 1 centimeter is equal to 0.01 meters. But because we're making our bigger unit 1, or to make this 1 you have to multiply it by 100, we get 100 centimeters equal to 1 meter, right? Because our bigger unit is 1. That means you can also convert this 100 to 1 times 10 to the 2 centimeters is equal to 1 meter. Right, and so this is basically what we have here minus the sign. So we make that sign positive. So one last thing before I go is right here. Our volume units, right? And so I said down here that liters is our chosen unit of volume. Right here we have meters cubed. Why? Well, typically we talk about milliliters, right? Milliliters of water. And this only works only for water, because water is a special case. Because it's pretty cool, because 1 milliliter of water is equal to 1 gram of water and is equal to 1 centimeter cubed of water. Right, so even though this has the volume and we're used to milliliters instead of meters, we see that 1 milliliter is equal to 1 centimeters cubed of water, right? And remember this only works for water, right? And so this is the reason why here you have meters cubed, but here I'm talking about liters as our volume, because most of the time we will be working with water, and this is just a simple conversion that you can do, just to switch back from meters to milliliters. So that concludes my video on SI units. If you have any more questions, please refer to your workbook. It has a pretty good explanation there, or even just ask your peer leaders if you're still kind of stuck on this. So that concludes this video, and we'll see you in the next one.